Okay, um, so welcome to our little t-test how-to video for Excel. And in order to actually perform what we're about to do and do everything correctly, um, what you're going to want to do is first download the demo file that has the data in it, and you have to make sure that you have the data analysis pack, or what's called the Analysis Toolpack, installed in Excel. And so if you have not done that yet, um, follow the directions on Blackboard for how to do that. And you can actually test whether or not you have it installed by in Excel. Whether you have Mac or PC, go to the Data tab. And if you have it installed, you'll see a little button like this. It says Data Analysis. You click on it and it gives you a list of analyses that you can perform. So if you don't see that under your Data tab, you're going to want to go ahead and go to Blackboard, and on there's a link to the Microsoft Office um, how-to page to show you how to install that. So make sure you've done that. So if you have done that, we're going to run through the companion to our lecture, just kind of running you through how to actually get data from the data themselves to the two types of t-tests. So we're going to start with correlated samples. This is, again, t-tests in which we have two pieces of information from one set of people or families or whatever else it is. So Excel calls this a t-test for paired two-sample means. By the way, this PDF that we're looking at is also on Blackboard. So we're going to just go through it. So if I open up my data, now I've already completed it, so I gave you that so you could see that. So let's go ahead and actually make a new tab, and we're going to copy and paste just these three columns: the family column, the before, and the after column. So I'm going to go ahead and copy those into my new sheet and zoom in a little bit more. Okay, so the reason I'm doing this is to show you that for the purposes of getting effect size, the first thing that you're going to want to actually do is compute difference scores. And by convention, you can just do the first column minus the second column for each of these. Right? So now that I've done it in one, I can hover over and drag this down, and I now have, right, you can see B3 minus, so this minus this, right, this minus that, so on and so forth. So you need to have a column here which represents each family's before consumption, before campaign consumption, and their after campaign consumption, the difference, right? 55 minus 48 is 7. For effect size, we're going to need the mean of the difference scores. So we're going to go ahead and get that here with average. As we see, you'll see in the lecture, it's about 2.92 gallons. And notice this positive number means that on average, families consumed more gas before the advertising campaign than after per month, which is, of course, what you would hope. And again, this is just simply the average of these numbers, including the negative numbers, right? So it averages out to about 2.91 gallons of a difference in gallons per families. To get the standard deviation, we use our regular stdev.s function. And again, we're using the sample data. Be careful not to include the mean in there, right? Since these are numbers, we can get their standard deviation and we have it there. So I like to do that first. This is going to set me up for later. And you can look back at the slides to see what we do with that. Let's go ahead and follow the directions for actually computing the t-test. So instead of typing in syntax to use the data analysis pack, we point and click. So the first thing you want to do is go to the data tab. And this is in Excel. This will be in Excel on Mac and PC. And over on the right-hand side, there'll be a data analysis button. So you click that. And note, if I scroll up, it gives me a lot of options. The correlated groups design, as it's described in the book, requires what Excel calls a paired two-sample t-test. And so we're going to click that paired two-sample t-test. We're going to click OK. So if we follow along in the document, right, we see that we've got to fill in some stuff in there. So the first thing that we want to fill in is we want to assign a variable range. So that just means we have to tell Excel where the numbers are. So I'm going to use that. I'm going to click on that box. And now this allows me to go into my sheet and click and drag. Now watch what I'm going to do. I'm going to include the label for the column. So I select that whole thing and I press enter. Now I want to go down here to labels and click that. What that's going to do is in the output, now it's going to label statistics from before and statistics from after. Okay? So we've got our before data in there. It's right there. We've clicked labels. Now we're going to get our after data again. Right? Make sure you select the labels and make sure this is checked. We don't have to put the different scores in there. It's just Excel's going to do that in the background. What we do have to do, though, is type in the hypothesized mean difference. This is the value of the mean of the different scores that we would expect if the null hypothesis is true, and that is 0. Okay. Alpha's in there as 0.05 by default. We could change it, but we're not. We're just going to use the regular old 0.05. And I think it's handy to get my output within the same sheet. So I click on this output range, and then again, I'll just select you want to select a cell over here because the output's going to be big. So this is just saying I want the output to start here. Okay. So I've got my data in here. I've made sure I've typed 0 in this box. I make sure labels box is checked. Alpha says 0.05, and I specify here's where I want my output to go. I press OK, and there it is. All right, so let's take a look at it. What Excel gives me is it gives me now, instead of the difference, the mean difference, it gives me that on average, these numbers average out to 48.92 gallons a month before the ad campaign, 46 afterwards. And by the way, if I subtract this number from that number, I get that number. Variance, we can just ignore that for now. We could turn those into standard deviations if we want, but we're not going to do that. Note it tells us that we've got 12 observations in each one. The Pearson correlation is just why we call it correlated groups. This is the actual correlation between these gas consumption before and after, and it's quite high, which is what we would expect, but we're going to ignore that. So the first thing we see here is we see our degrees of freedom of our test. And again, in the lecture, you'll see that we want to report that with our t statistic. This is our actual t value. So this is like a z value, but it's a t value. And this t value goes with our mean difference. They're very close in numerical value, but they are of very different conceptual values, right? They come from a different computation. Also note, if I just make this a little bit bigger, that Excel gives me several options down here. It gives me 2 types of p-values. It gives me that 1 tail and 2 tail. It also gives me these critical values, which we're not using that method, so you can just ignore those. But that's another way to do a hypothesis test. We're using the p-value method, and we're going to use a 2-tail p-value, which we see right here, not the 1 tail, but the 2 tail. And so we would take that and we would compare to 0.05, and we've got what we need. So again, you can take a look at the lecture to see how we would use that. But essentially, this is evidence, this p-value, if our alpha is 0.05, our 2-tail p-value here is less than 0.05. So this t statistic and its p-value would suggest that we should reject the null hypothesis that people don't change, right? That's the null hypothesis. We should reject that and say, wow, the advertising campaign worked, right? Because we got an average of almost 3 gallons less that people used after the campaign, right? So the final thing that we're going to do, and again, you'll see this in the lecture, is Cohen's D, effect size. For correlated groups design, Cohen's D is simply just the mean of the different scores divided by the standard deviation of the different scores. Super easy. So that's why we wanted to calculate that, right? You have to do this by hand in Excel. It's the only way it comes out. And we press enter, and again, we rounded 2 decimal points, and that's approximately an effect size of 0.84. So if you look at your document, you'll see that all of that is in here for you. And so you're going to want to try to reconstruct that. And again, just a reminder, one-tailed test, you look at this value, two-tailed test, you look at this p-value, and we're good, okay? So that's the correlated groups design, or paired t-test. Let's have a look at independent groups. And again, in the lecture, we'll see that the data here are from a study of rats and thalamus lesions and pain perception. So again, I've given you the full output here, but let's go ahead and take, so these are the data from rows 2 to 10. So let's copy and paste that in a blank sheet to work through it. Now, a couple things to note. Not the same amount of participants in each group here. That's allowable in this type of test because this is a different set of rats, okay? So again, I always like to get descriptive statistics first. Let's get the mean and the standard deviation for each group. And remember, these values are basically shock intensity in milliamps of current, which is how you measure current. So it's very mild shock, but the interest is whether or not the experimental group on average has a higher threshold, meaning that they can tolerate higher values than the control group, right? So let's first look at that descriptively. And note, Excel's going to calculate these for you, but it's always handy to be able to do it on your own. So we do see that the average shock tolerance is higher in the experimental group with the thalamus lesions, which is what one would expect if you damage part of the brain that is involved in pain perception. You won't feel as much pain, and so we seem to have some descriptive evidence for that. We'll get our standard deviations because we're going to want to report those later. And again, make sure you don't include the mean in there, just the data. And again, with this one, right, don't include that blank cell because that's going to, Excel's going to interpret that as a 0. You don't want to do that, right? Now, an important note is we want to make sure these values are pretty close. That's an assumption of the type of t-test we're going to perform. And, for the purposes of pedagogy, all the examples in the book are going to have this satisfied. But if you were ever doing analyses and you computed standard deviations of your two groups, and one was, say, like 2 times bigger than the other. So if this was like 0.8 or 1.5, you might have a little bit of a problem, but we don't have to worry about that right now. Okay, so following along here, we're going to do data analysis again, but now we're going to select a different t-test. We're going to select 2 sample assuming equal variances. And again, that's assuming that these 2 numbers are about equal, which is approximately true here. So again, we hit our data tab, data, and then we hit data analysis. And right underneath the one that we just did is the 2 sample assuming equal variances. This is what is appropriate for an independent group's design. So we click OK, and we see that we have something that looks almost identical to before, and it's going to work very similar. It's just going to give us different results. So again, we want to go ahead and select our data. Now, again, you can include the labels. Right? Don't include the mean. And including labels, you also have to tell Excel that you've included labels or you'll get an error. So make sure that box is checked. Then we go to our second, right? And again, make sure you stop. Don't include that blank cell, all right? And again, we have to tell it that we hypothesize the mean difference to be 0. We could hypothesize other values, but we're going to use null hypothesis significance testing. So we type a 0. And again, I think it's nice to have our data in the same output sheet. So we'll put it right here. Okay, so that's get your data in there. If you're including the label for the column, you got to check that box. You have to type 0 here. 0.05 is in there by default, so you don't have to change it if you don't want to. And now we click OK. And here's our output. Now this is a little bit different than before because this is a different t-test, right? We have a different design. Note that we've got our means, and Excel computes variances rather than standard deviations, so that's why you do it yourself. We see that we have different number of observations in the two samples. And then we have this thing called pooled variance. This is, as you'll see in the slides, this is a very important component of the output because we need this for effect size. Okay? But we're going to ignore that for a minute. Let's look at the results of the t-test. Okay? This tells us that we're using a test with 13 degrees of freedom. Now in the slides, you'll see that in a two-sample independent groups t-test, the degrees of freedom is always equal to the total sample size. So 8 plus 7 is 15, minus 2 is 13. And we have to report that value along with our results. Again, that allows people to make sure that our p-value matches with our t-statistic. We see that our t-statistic is actually a negative number, negative 2.938 or negative 2.94. So why is it negative? Totally fine for it to be negative. It's a function of the difference between the mean for the control group and the mean for the experimental group. In Excel, because you inputted the control group as variable 1, it takes this number minus that number, which is a negative number, and then divides by the standard error in this distribution, which I wasn't showing you how to calculate because it's a little complicated. That's why we have a negative number. That's just showing, basically reflecting the fact that the control group had a lower pain threshold than the experimental group. Down here, again, for a two-tailed test, we have our two-tailed p-value. It's 0.0115. And again, we ask the question, as you see in your little guide, and here's the same results, right? Two-tailed test, we look at that two-tailed p row. If it's less than alpha, we reject the null hypothesis. So with an alpha of 0.05, this is less than alpha, so we reject it. And so there you have your t-test results. Now Cohen's d for a two-sample t-test, we need the difference between the means. Okay, so we need to do, so you can use these data here or these. So I'll use ours, is this minus this. And notice that that's negative, but we don't want a negative number for Cohen's d. Okay. So there's a way we can do that that I'll show you in a minute. But before we do that, we want to get what's called pooled standard deviation. What is pooled standard deviation? It is the square root of the pooled variance. Right? So we want that pooled variance value in there. We're going to take its square root. Okay? Now, if you look in the slides, you'll see these numbers on the slides. Okay? Now, the one thing we want to do is we want to get rid of that negative sign. There's an easy way to do it. Okay? Anytime we want to take the absolute value, we just type in ABS for absolute value. So we're going to take the absolute value of this divided by this. And we get our 1.52 as before. Now, if I didn't do that, if I did just simply did equals this divided by this, I get the same result just with the negative sign there. So you don't necessarily have to do that. But we we're going to interpret Cohen's d in magnitude by dropping the negative sign. And so we have a large magnitude Cohen's d here. And so we're going to interpret it that way. Okay. So that's it for using Excel with point and click here. Make sure you've mastered that. And again, the actual lecture will show you in context what all of this means. And again, please email me with questions that you have.